for this video, we're doing adding and subtracting fractions with unlike denominators. Just want to start with a quick little visual here. So here we have two fractions that we're going to add together. So this one is a half, and this one is 1/4. Now, as we know, the first rule of adding and subtracting fractions is we have to have common denominators. We do not here. So our step then is we're going to find an equivalent fraction that will allow us to have the same denominator on each of the fractions. And so really what that's saying here is if we look at this visual, it's going to change the color here. So I have different denominators. I have a 4 and I have a 2. I need those to be the same. And so the first step that I always like to say is you look at the larger denominator and you say, is this a multiple of the smaller denominator? In other words, is 4 a multiple of 2? In this case it is. So we want to make both of our denominators 4 because that's the least amount of work for us here. So we can leave the 1/4 the same, and we're going to change the half into quarters. So what that looks like basically is we need this one divided into quarters. So it's already in halves now, it's in quarters. So changing that fraction now is that fraction we now have 2 out of 4 possible, plus this one's already in quarters, and we're adding those. So then if I take this quarter here and I add it to here, what's my answer? 3/4. So all we're doing when we're making equivalent fractions is we're adjusting the size of if we're looking at a visual, of the number of possible spaces to make up a whole, and then we're able to add the pieces together because they are a common size. So how does that look just if we're not having a visual but we have just two denominators? So let's say that we're doing 1/3 plus 2/6. Okay, so in this one again, the first step, first I look at it and I'm like, okay, those aren't the same. So now I got to see, is the larger one, the 6, a multiple of the 3? It is, so I'm going to change these now to 6. So that one stays the same. I need this one to become 6. So how, looking at the denominators, what do I multiply this by to get 6? Times it by 2. So I have to multiply the top number by 2 as well. So then this one becomes 2. So 2/6 plus 2/6 equals, and again the rule is the same. We keep the same denominator, and then we only have the top 4/6. Now this one here, for this example, we have to reduce. Looking at it, so we see they're both even, so I'm just going to divide by 2. That's the greatest common factor. So it's going to give me 2/3 is going to be my answer. So 1/3 plus 2/6 is 2/3. Let's try another example here. 1/4 plus 3/16. Okay, so again, different denominators, so now I have to make them common. Is 16 the larger one a multiple of 4? Yes, it is, so I'm going to change these to 16ths. That one stays the same. This one I'm going to 16, so to do that I multiply this by 4. So multiply my top one by 4. So my equivalent fraction to 1/4 is 4/16. So now I can add them together. That add the top, the numerators, keep the denominator. 7/16 is my answer. Let's try one here. Well, let's do one more. So 2/3 plus 2/18 of all random ones. Okay, so we got 2/3 plus 2/18. Again, not common, so I look and see, is 18 a multiple of 3? Yes, it is, so I'm going to keep that the same. I'm going to go to 18ths. Okay, 18ths. I got to times that by 6 to get there, so I'm going to times that by 6 as well, so that gives me 12. Okay, now add them together, keep my 18, that's 14. Got a couple even ones here. That's an instant tip that I need to reduce. I'm going to divide these each by 2. That's the greatest common factor between the two of them. So that gives me 7/9 as my final answer. Okay, well, let's try one where, let's say 1/3 plus 3/5. Okay, so I see they're unlike denominators. Then I look at the large one, the 5. Is that a multiple of 3? No, it's not. So now we're into these types of questions where we have to find the lowest common multiple, and we're going to change both of these to find equivalent fractions that now have the same common denominator. So again, the way I do it is I take the larger denominator of 5 and I start writing down the multiples until I find one that's also a multiple of the smaller one. So in this case, the 3. So 5, 10, 15. 3 times 5 is 15. So that one works for this one. So I'm going to go to 15ths. Now again, it works if we skip to another one. 15, 20, no. 25, no. 30, yes. So I could also do 30s on this, but that just makes for more reducing in the end. So I'm going to go to 15. So if I do this one first, so that's times 3 times 3, so that's 9 over 15. Is that equivalent fraction? And then 3 times 5, so 1 times 5. So 5 over 15, is that equivalent fraction? So now I can add them together, so that 9 plus 5 is 14. 15ths is my answer. Okay, let's do another, wrong button. Another example here. So if I do, let's see, we'll do one more, then we're going to do a worksheet one. So let's say that I do 1/4 plus 3/5. How about that? 1/4 plus 3/5. Okay, again, so not common, so I look, 5 is not a multiple of 4. So I do the 5, 10, 15, 20. So 20 it is. Okay, if you want to see why, 4, 8, 12, 16, 20. Okay, lowest common multiple. So we got 20s here. Okay, so that's times 5 times 5. So we got 5 over 20 times 4 times 4. So that's 12. So it equals 17 over 20. So that's my answer there. Now, does this work the same for subtraction? It does. So let's try this one. 3/5 subtract 1/3. Okay, 3/5 subtract 1/3. Same thing, 5 and the 3. 5 is not a multiple of 3, so I got to find the lowest one. It's 15. Again, we've got that one, so it's going to work the same. Times 5 times 5, so that's 5. Times 3 times 3, so that's 9. Okay, so 9 subtract 5 is 4 over 15. Okay, so it works the same way. We just follow the rules. Everything's exactly the same. It doesn't really change. 2/3 subtract 1/8. There we go. Let's try this one. Okay, so not the same. 8 is not a multiple of 3. So I got to find the lowest. So we've got 8, 16, nope. 24, yes. 24 over 24. What do we get there from this? Times 8. Times 8 is 16. Times 3 times 3 is 3. 16 subtract 3 equals 13 over 24. Okay, so it works exactly the same for subtraction. All the same steps, just in the end, you subtract. So looking at a worksheet here, I'm not going to do all these, I'll just do a couple of them, and I can just walk through these. So I'm adding, this one's got the arrows there to show to drop it down and show it across. So it's the same steps I was doing here. It just shows it for you there. So again, not common, so I look, 6 is a multiple of 2, so perfect, I'm going to use 6. That one just comes straight down. Times 3 times 3, 3 over 6. Okay, 1 plus 3 is 4 over 6. I can reduce that, dividing that by 2, divided by 2 equals 2/3. Okay, 1/4 and 3/8. 8 is a multiple of 4, so I'm going to use 8 times 2 times 2. So this is going to be 2 over 8. That gives me 5 over 8. Okay, the next one there, 8 is a multiple of 2, so I'm going to keep 8 times 4 times 4, 4 over 8, so that also gives me 5/8. Okay, all of these on this page here, 10 is a multiple of 2, so I'm going to keep 10, so this one says 210 times 5 times 5, so that's going to be 5 over 10 equals 7 over 10. Okay, so it's just continual there working down. Look, some subtraction ones right here to show they're the same. Okay, so 2 and 8, we're going to go to 8. So this will stay at 5 and 8 times 4 times 4. So 8 and 4 subtract that, we got 1/8. Another one, 4 and 8. 8 is what we're going to go to. 8 is a multiple of 4. Okay, times 2 times 2 is going to give me 6 eighths. Subtract 1/8 is going to give me 5 eighths. Now, if you're wondering, remember, I want to see all of that work there. Okay, so you're showing this part because that shows you know what you're doing. Write it out. We won't make mistakes, especially ones like this one, where we're going to have to change both because we've got a 6 and a 4. 6 is not a multiple of 4, so I'm going to go 6, 12. Oh, 4 goes into 12. So we're going to go to 12s. Okay, for 6's to get to 12, you got to times it by 2. So I times that by 2, so that's 10. 4 to get to 12, I got to times by 3, so I got to times this by 3, so that's 9. 9 over 10 subtract, or 7, sorry, 10 over 12 subtract 9 over 12 is 1 over 12. Okay, so those are the steps. Please make sure you show all your work. If you want more examples, you could always start the video over, or you could just practice them on your own. Come and see me if you need any help with adding or subtracting fractions with unlike denominators.